So in section 5.2, we get into more accurate representations of estimating the area under the curve. And so here we have, this is an integral, so we have the integral from 4 to 8, and then this is the equation, 32 minus 8x. And so first we have to find our delta x. So our delta x is 4 over n, and our I delta x is 4 plus 4I over n. So then we take our integral. So we have integral of 4 to 8, 32 minus 8x dx. And then we're going to translate that into a limit. So the limit as n approaches infinity of, so we have from n to I equals 1 sigma f of 4 plus 4I over n times 4 over n, and that equals the limit as n approaches infinity. 4 over n, we can pull that out because it's a constant. So we have sigma n to I equals 1. And we have our equation, 32 minus 8. And we're substituting for x, our 4 plus 4I over n. Close that off. Then we can come back down. And so now we have limit as n approaches infinity, 4 over n, because that's our constant, so we can pull that out. Sigma n I equals 1. And then we can split that up. So we have negative 32I over n. So that's what we have from there. So once we simplify that, we get 32I over n. And then equals limit of, as n approaches infinity, 4 over n. We can pull out negative 32 over n. And I approach it equals 1 sigma I. Then we can move down more. And so now we have limit as n approaches infinity of negative 128 over n squared. And then we have n times n plus 1 all over 2. And then continue on. Limit as n goes to infinity of negative 128 over 2 times the quantity n plus 1 over n. And then we can simplify that to negative 64. Limit as n approaches infinity. And then we have 1 plus 1 over n. And then this equals negative 64. Plug in our 1, and our answer is negative 64. So that is our area under the curve. And another thing we can do is, with this equation, we just get a straight line. So what we can do is just take the area, calculate the area, and then find the area under the curve. So for this is a positive area since it's above the x-axis, and this is a negative area since it's below the x-axis. So what we do is we take this area and subtract this area because that's taking away from how much area is under the curve. So this is a triangle. So area of a triangle is 1/2 base times height. So it's 4 by 4. So 1/2 times 4 by 4. So this is 1/2 of 16, which is 8. And then this is 1/2 by 1 by 1. So 1/2, 1, 1. And this is 1/2. So what we're going to do is 8 minus 1/2. So we're just going to make 8 1/2 have a common denominator, so 8 times 2 is 16, so we're going to have 16 over 2 minus 1 over 2, and then we end up with 15 over 2, and that is the area of this graph right here.